Hey y'all, this is Mr. Carey coming back at you, and it's time for another GoMath lesson. And if you're reading this, that means you have already successfully completed the Chapter 7 mid-chapter checkpoint. Hopefully you did well. If you're like me, or the teachers like me, they probably graded it. Hopefully you did well. And if they didn't, well, consider yourself lucky. But my students all thought it was a pretty easy test. They liked it. But then reality sets in lesson 7.6, and we start getting into mixed numbers and improper fractions. Now, I'm going to start off a little bit different because I want to go over some key vocabulary terms, which they don't really talk about in the book. They do, but not really like how I would explain it, and I think my way is better. So I'm just going to go with that. And by the way, I'm going by Mr. Carey, but I feel like we know each other now. I feel like I'm getting to know you, you're getting to know me, and more importantly, you're getting to know math and language arts. So I think you can call me Mr. C if you'd like, or you can call me Mr. Carey, whatever. So let's kick into it first. Now, there's going to be two big vocabulary terms you're going to learn. All right, two big ones. All right, the first one is going to be a mixed number, right? And I'm gonna dial. That's really big. I'm gonna dial that down a little bit because that's a little bigger than I need it to be. We're at a 67. Let's put that at a 40. That's much better. All right, a mixed number, right? Now, instead of me giving you a whole bunch of numbers or a whole bunch of words and defining like the book does, I'm just gonna draw out some mixed numbers for you, right? A mixed number is nothing more than a whole number, right? I don't know, 2. And then a fraction, 2 and 1/2. That's a mixed number. You don't like that? Fine. What about 5 and 3/4? What about, I don't know, let's do 100 and 1/10, right? Or how about 1 and 1/3? All right, these are all mixed numbers. Why are they mixed numbers? Well, the first thing that makes it a mixed number is I have a whole number and I have a fraction, right? So it's mixed, right? A whole number and a fraction, it's mixed. And that's all it really is. Now, the book gives you definition, which we're going to go into it once I put my screen up. But really, I want you to get used to looking at mixed numbers, right? You see this. You see a whole number and then a fraction. That's a mixed number. Now, we're going to learn how you can go back and forth between a mixed number and our next thing we're going to learn. But keep in mind, right, that when we talk about a fraction, and this is like a good review for us, right? For those that are still kind of struggling with, you maybe know what a fraction looks like, but what is a fraction? Well, a fraction, if I could spell it correctly, a fraction is really nothing more than a part of a whole. That's it, right? That is a fraction, right? A fraction, right? Why is 1/2 a fraction? Because I have number of something. Now I'm going to put number of pieces. And this is how many pieces? How many pieces I have. Or have eaten, or used, or what, it doesn't matter, right? But a fraction is a part of a whole, right? I had 1 piece, and now I have 1/2 of a piece. That's a fraction. Now, we're used to seeing fractions like this, and it's really nice and neat, right? You got the numerator. I'm going to circle this in green. Got my numerator, and it's super cool, and it's small. And then we have our denominator, and that's always bigger. And that is how the world should work. Everyone's happy. But I'm about ready to wreck that right now. When I delete all that and I show you, I'm going to delete all that and hope you all have that. But hey, if you didn't, just go ahead and click pause and copy this down. I'm going to show you this. If I can spell correctly, wow. Improper fractions. Now, they don't really talk about this in the book. They show you it and they just say it's a fraction, but it's an improper fraction, right? Why is it an improper fraction? Well, it has nothing to do with the fact that it doesn't drink tea with its pinky out or it doesn't speak in a British accent. Ah, yes. Thank you, faithful rimshot. Yes, that is a joke, a math joke, if you will. Not a very good one. But an improper fraction, right? I'm going to do, let's say, 13 over 4. Or 7 over 2. Or how about 3 over 2? Maybe 100 over 99. And just for, just to be fun, I don't know, 11 over 7. These are all improper fractions because I'm sure you can look at the difference between an improper fraction and a proper fraction. Yes, just kidding, I had to do that. Now, the key thing is my numerator is bigger than my denominator. And that's okay, right? You can have fractions like this. I don't like looking at them, but it's totally fine to have fractions like this. So, mixed number. I've got a whole number and a fraction. Improper fraction, my numerator is bigger than my denominator. And that's all it is, right? And that's what we're going to kick into in lesson 7.6. And this is your introduction to proper fractions, improper fractions, mixed numbers. And so what I'm going to do is I'm going to pull up lesson 7.6 and boom, there it is, just like magic. All right. Now, if we look at our essential question, you're probably like, Mr. Carey, no one reads the essential question. Well, I do. And you should probably do that too. Because really, it says, how can you rename mixed numbers as fractions greater than 1 and rename fractions greater than 1 as mixed numbers? Mr. Carey, what is a fraction greater than 1? Okay, fraction greater than 1 is an improper fraction. I need to change my pen because it's like really thick. It's like I'm drawing with like an expo marker. Improper fraction, right? This is great. That's much better. Is greater than 1. 3 over 2 is greater than 1. If you don't understand that, it is totally fine because we're going to do that right now. Okay, erase, erase, erase. Okay, so let's kick into it, right? Mr. Fox has 2 3/6 loaves of cornbread. Okay, that's kind of awkward, but 2 3/6 loaves of cornbread. Each loaf was cut into 6 size pieces, 1/6 size pieces. He has 14 people over for dinner. Is there enough bread for each person to have 1 piece? Okay, fine, we'll figure that, and that's a lot, right? Basically, does Mr. Fox have enough to feed everybody? He's got 14 people coming over. Does he have enough cornbread? Okay. Well, let's look at this. I give you my definition for a mixed number, and that's a good, it's a good definition too. A number represented by a whole number and a fraction, right? 1 1/2. Or in the case of Mr. Fox, 2 3/6. Here is my whole number, and there is my fraction. Okay, that's a mixed number. All right, let's get on with Mr. Fox. Now, before we figure this out, before we jump into this, we need to find out how many 6 size pieces are in 2 3/6. All right, let's answer this. What is the size of 1 piece of bread relative to the whole? That is a really fun and confusing way to say, what's my fraction, right? What's the fraction I'm going to be using? And if you're not sure, what is my fraction? 1/6. Everybody gets 1/6 of a piece, right? That's their slice. That's what they get. So before we jump, how much bread does Mr. Fox need for 14 people? Well, we don't really know yet. We need a lot of it. So let's figure that out. All right. Step 1, write a mixed number as a fraction. So we're going to model 2 3/6. Now, here we go. There's 1, 2, and then 1/6, 2/6, 3/6. Now, there's got to be a different way, right? So there's 1 and 3/6. Well, that's pretty easy so far. Nothing really different. I just spread my 2 into 1 and 1. All right, and I just wrote over my 3 because and that's making it even worse. Whatever, you know it's 3 6. All right, now step 2. Find out how many 6-sized pieces are in each whole. All right, so this is something you can write the number 1 as whatever fraction you want. You want to write it as 2 over 2? Go ahead. You want to write it as 100 over 100? Fantastic. Go ahead. You want to write it, in this case, I'm going to X these out, as 6 over 6? Absolutely. Because what does this mean? This means I am cutting my cornbread into 6 pieces, and I have 6 pieces, which means I have a whole. I mean, that's it, right? So now we're going to do step 2. How many 6-sized pieces are in each whole? Well, let's count it up. My first whole, there's 1 6, 2 6, 3 6, 4 6, 5 6, 6 6. Well, boom, there we go. Let's do my next whole. 1 6, 2 6, 3 6, 4 6, 5 6, 6 6. There we go. And then how many 6 are left over? 1 6, 2 6, 3 6. Okay, so far so good. And now, guess what we need to do? We need to add this up. Remember, when we're adding fractions, you just add the numerators and leave the denominators alone. So, 6 plus 6 plus 3. Let's check it out. 6 plus 6 is 12. 12 plus 3 is 15. And remember, my denominator stays the same. So there are how many 6-sized pieces? We have 15 6-sized pieces. How many did we need? We needed for 14. Now, I forgot to kind of answer this question. How much bread does Mr. Fox need for 14 people? Okay. And I did this morning for my class, and they seemed to kind of like the answer was right in their face, and they were like, I don't want to say the wrong thing. If 1/6 feeds one person, if I need to feed 14 people, how many am I going to need? And look at this, 1, I need 14/6 to feed 14 people. I have 15/6, so Mr. Fox has 1 left over. Maybe it's for himself. I don't know. All right, so that is our first page with lesson 7.6. All right, and we're going to go over some of this, but that is taking your mixed number, right, and you are changing it into an improper fraction. So 2 and 3/6 is the same as 15/6. Now, in another video, I'm actually going to show you a little shortcut way. I'm not going to do it yet because I want you to make sure and get this. If I just teach you the shortcut way, you're not going to understand it and why you're doing it, and then you're going to be like Mr. Carey 30 years later wishing you'd had Common Core when you were growing up. Okay, so let's go ahead and go to the next page, and here it is in 5, 4, 3, 2, 1. Boom, right there. Okay, so now we're going to switch directions, right? We went from a mixed number to a improper fraction. Now we're going to go from an improper fraction to a mixed number. Now you're probably wondering why I'm doing that. Don't worry, I'm going to show you and explain why. All right, so we're going to read through. To weave a bracelet, Charlene needs 7 pieces of brown thread, and each thread must be 1/3 of a yard long. How much thread should she buy to weave the bracelet? All right, that's pretty easy, right? We already have our answer. Each piece must be 1/3. So 1 piece equals 1/3 of a yard, okay? She needs 7 pieces. So what would that be? Well, that would be 7/3 of a yard. Done, right? Well, no. Try going into Joann Fabrics, one of my favorite stores. I do like Michael's. They have good discounts. But try going into Joann Fabrics or Beverly Crafts and saying, you know, I would like 7/3 of a yard, please. Like, they're going to look at you like crazy. And they're going to say, what? And you say, yeah, 7/3, right? We're doing improper fractions. So we don't talk like this. We don't ever use 7/3 or 14 seconds or anything like that. So for it to make sense, we need to convert that into a mixed number. And how do we do that? Well, I'm glad you asked. So the whole point of this, we're going to model 7/3. So this, now remember from my last, was it chapter 7.4, 7.3? Each one of these individual fractions is called a unit fraction. Okay? So how do I break apart 7/3? 1/3 plus 1/3, and then you get the hang of this, right? Now, why am I doing this? Well, because the boxes are there and I have to fill them in. No, really, this will make sense. Because that's, in order to figure out how many holes you have, you need to figure out how many thirds do you have. So if we have 7/3, that means we have 7 1/3. Now, step 2, find out how many holes are in 7/3. Okay, well, can we agree that 1 hole is equal to 3/3? Where did I get thirds? I have to stay with thirds right there. Can we agree 1 hole is equal to 3/3? Sure, I would agree with that. So 3/3, 1, 2, 3. There's 1 hole. 1, 2, 3. There's another hole, and then I have 1 little third left over. Okay, now all you have to do is just add them up. 1 plus 1 is 2, and then you have your 1/3 left over. So Charlene should buy, now if you went into Joann Fabrics and said, I need to buy 2 and 1/3 of a yard of thread or fabric or whatever else, that's going to make a lot more sense. And they'll say, oh, okay, but if don't go, you know what? Do this next time. When you're with your parents, go somewhere and ask for 7/3 of something, right? And you're going to get some strange looks, and then you're going to say, aha, Mr. Carey was right. All right, moving on, we're going to share and show. Really, it's just me sharing and showing you, but you're welcome to share and show with anybody else you like. So the top part, right, here are my mixed numbers. That is a number sign. It's not a hashtag. I mean, it is a hashtag. It's a number sign. It's also a pound sign. I know you kids like to call it hashtag. Fine. But if this helps you out, mix numbers. Good. And the bottom are my improper fractions. And you're going to see a pattern here, and this will help you kind of understand how we convert this, right? So I have 1, 1 and 1/6, 1 and 3/6, so 1 and 2/6. 1, 2, 3, 1 and 4/6, 1 and 5/6, and then 2. This is also, if you want to be fancy, 1 and 6/6, which is the same as 2. And then you have 2 and 1/6, 2 and 2/6, 2 and 3/6. Do we see a pattern here? Sure we do. 2 and 4/6, 2 and 5/6, and then 3. And now we're going to go to the bottom. And all we're doing is just counting across the top. Right? 6/6. I have 8/6, so let's do 7/6, 8/6, 9/6, 10/6, 11/6, 12/6, 13/6, 14/6, 15/6, 16/6, and so on and so on and so on. So you're going to see some similarities here, namely with this right here. And I'm going to cover that in my extra video, which kind of goes over some ways to figure out how we can solve this. And you're going to see some similarities here and here. So 6/6 is 1, 12/6 is 2, 18/6 is 3. Now I want you to look at the relationship between 6/6, 12/6, and 18/6. I want you to look at that keep it to yourself, and then we're going to move on to our last page, and then I'll cover it in our little addendum video. All right, so coming up with the last page, I'm going to do this all the way to 5, 4, 3, 2, 1, boom. I'm not going to do on your own. I'm just going to work through, I'm going to work through these right there. Okay? So let's go ahead and do with that, because then I'm going to have you do the rest of this on your own. I'm not going to do your classwork for you. This is just to kind of reteach it. So, first one, write, now this is important to read the directions, write the mixed number as a fraction. All right, so if I have 1, okay, look at my denominator as an 8. I have 1. How can I write 1 as a fraction using 8 as the denominator? Now, if you said 8 over 8, I would say you're absolutely correct. But I have one little thing left over. I've got my 1/8 left over. And now you just add up. 8 eighths plus 1/8. 8 plus 1 equals 9 eighths, which is exactly the same as 1 1/8. All right, let's do 1 3/5. So, how can I write 1, the number 1, a whole number, as a fifth? Or using fifths? Right. 5/5 is the same as 1. And how much do I have left over? I have 3/5 left over. 5 plus 3 equals 8/5. Cool, right? I mean, I think it's cool. Now, 1 2/3. So how can I write the number 1, a whole number, representing it in thirds? Sure, I can do 3 over 3. Plus, what's my fraction left over here? 2/3. 3 plus 2 equals 5/3. Boom! Super easy, right? Now, let's go ahead and go the other way. We're going to write our fractions as a mixed number. Now, we're going to go, if I have 11 over 4, right? Now, I'm going to do it the way that they do in the book. My next video, right after this, I'm going to show you some kind of cool magic of how you can do this a quicker way and still kind of understand what you're doing. One of my students made a great connection, which I want to share with everybody. Okay? I have 11/4. Well, okay, 11 over fourths. How many fourths is that? Well, 1/4, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wow, that's super exhausting. Okay. Now, what are my wholes? How do I make a whole using fourths? Well, 4 over 4 equals 1. So what I'm going to do is I'm going to highlight all of my wholes, and I'm going to do different colors. 1/4, 2/4, 3/4, 4/4. That's one whole. 1/4, 2/4, 3/4, 4/4. That's 2. And then I have how many fourths are left over? I have 3/4 left over. So I have 2 wholes. And I'm going to have to, I'll put it here, 2 wholes. And how many fourths do I have left over? 2 3/4. Cool, right? All right. And let's figure out 6/5. And you're just going to, what I like to say, decompose or decompile the fractions. 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. That should take me to 6. 1, 2, 3, 4, 5, 6. Good. And I'm going to highlight my whole. Maybe highlight it. Maybe do that instead, huh? There we go. Highlight. 1/5, 2/5, 3/5, 4/5, 5/5. So that's, how many wholes is that? 1 whole. And what do I have left over? 1/5. Perfect. Now 13/10. Fine. I don't, you're probably like, gosh, Mr. Carey, do I really got to write this all out? Well, for now you do, yes. But I'm going to show you an easier way in the next video. So 13/10. Actually, I don't even need to, I'm just going to erase that, and I'm going to do this. Equals 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, 11/10, 12/10, 13/10. Wow, that's kind of exhausting. All right, now how many wholes do I have? Well, 10 over 10, I need 10/10 to make a whole. So let's take a look. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that. So how many wholes do we have? We have 1 whole. All right. And how many tenths are left over? 1, 2, 3. 3/10. All right. So this takes me to the end of chapter 7.6. Stay tuned because I'm going to show you 2 different ways that will make it easier to make a mixed number into a fraction and a fraction into a mixed number. All right, it should take about like 6 minutes to explain. I don't like to call them shortcuts, although they are, because it's really just you're using math, right? Using multiplication and division to figure out your fractions, right? And I'm going to tell you one of the key things of looking at fractions. Until that time, this is Mr. Carey, Mr. C, 4th grade teacher, hanging out with you on lesson 7.6, converting mixed numbers into fractions, fractions into mixed numbers. Hopefully you've had as fun with this as I have had teaching it. Again, stay tuned. My next video is coming right up. Until then, I will see you all later. Bye-bye.